Welcome back to the workshop. Let's see, we want to take a look at anti-differentiation today. So anti-differentiation, I like this word because it makes it clear what exactly we're doing. All right, if I say integral, I want to find an integral or calculate an integral or perform some integration. That's right. We know what that means, but it doesn't really give a good insight as to what exactly we are doing. And what we're doing is the opposite action of taking a derivative, right? We're not differentiating, we're doing the opposite. We're anti-differentiating. So that's what we want to take a look at in this video. And I think we'll just present essentially the definition. What is anti-differentiation? So it has a formal definition here. So an antiderivative, what is it? Well, so if we have a function f, capital F here, it is an antiderivative of a lowercase f on some interval, right? The interval idea is maybe just a detail that is necessary, but not always thought of. But capital F is an antiderivative of lowercase f if the derivative of capital F is lowercase f, right? If I can take the derivative and I get that, then I'm good to go. So if I want to find the antiderivative of this, I'm finding a function capital F that satisfies that antiderivative. I'm given this, I'm finding that instead of being given capital F and finding lowercase. Okay, so I'm working backwards. So if I want to talk about the general antiderivative, then we actually end up essentially throwing in this plus c. And why is it just a plus c? Well, that's something that we can take a look at again in a real analysis class, because then we're just talking about proofs. Likely something that you saw in Calc 1 already anyway. So when we talk about antiderivatives, we use this particular notation, which, right, this is an integral sign. So integration and antidifferentiation are right, closely related, essentially the same thing. Right, synonymous. Indefinite integral is synonymous with antiderivative, because integral is usually talking about definite integral, and then we're talking about an area, which is something a little bit different than just an antiderivative. So indefinite integral, antiderivative, thumbs up. Yeah. All right, so that's what we have. So if I want to, let's see, a really basic example here. So if I have, hey, a function that we've already seen, if I have f of x is x cubed, whose derivative, of course, we already know to be 3x squared, then, right, knowing this relationship allows us to calculate some integral. So having a good understanding of derivatives is what's going to allow us to gain our knowledge in antiderivatives, or have an understanding of antiderivatives. So if I want to find, let's see here, I have lowercase f is 3x squared. If I want to find the antiderivative or the indefinite integral of it, right, f of x is this thing. So the antiderivative of that thing is exactly x cubed plus c. Why? Because the derivative of this is going to give me back 3x squared. Again, derivative of a constant 0. So that's the idea with an antiderivative. So we'll take a look at a few examples in another video. So for now, we'll pause just for a moment, and we'll return to take a look at some examples. So I'll see you guys back in the workshop in just a minute.